Hello. So today we are going to discuss Lagrange's interpolation formula after Newton's forward interpolation formula and backward interpolation formula. We will study Lagrange's interpolation formula. In Newton's forward or backward interpolation formula, there is the spacing between x is equal, the spacing is equal for x values, but Lagrange's interpolation formula is exclusively for unequal intervals or unevenly spaced points. For constructing an interpolating polynomial, we use Lagrange's interpolation formula where the x intervals are unequal. So let y of x be continuous and differentiable. So the function here is y of x and it is continuous and differentiable in n plus 1 times in the interval ab, and given it is given n plus 1 points. As you know, n plus 1 points x0, y0, x1, y1 up to xn, y. These are the n plus 1 points. So we have to find an interpolating polynomial using these points. Here x0, x1, here we cannot write h is equal to x1 minus x0, xi minus 1. We cannot write h is equal to this must be unequal intervals. So that is the values of x need not be equally spaced. So we wish to find a polynomial of degree n. We wish to find a polynomial of degree n. Let us say it is, let L n of x be the nth degree polynomial that we wish to find out. So let ln of xi such that ln of xi is equal to y of xi is equal to, we can write is yi, where I is equal to 0, 1 up to n. Before deriving the general formula, we first consider a simpler case, that is an equation of a straight line passing through 2 points x0, y0 and x1, y1. Before going to construct a nth degree polynomial, we consider a straight line equation, first order polynomial, and the polynomial or the straight line is passing through 2 points x0, y0 and x1, y1. We can write L1, this is degree 1, L1 of x is equal to x minus x1 divided by x0 minus x1, y0 plus x minus x0 divided by x1 minus x0 by 1. This equation, you are familiar with this equation. This is the equation of a straight line. So let us write, let this quantity be L0, L0, Y0, L0 of x, Y0 plus this quantity can be written as, let us write L1 of x is this quantity, therefore L1 of x, Y1, where L0 is x minus x1 by x0 minus x1 and L1 is x minus x0 divided by x1 minus x0. So you note one point here, this is L0, this is L0, so here x minus x0, there is no x0 term in the numerator here, and this is L1 and there is no x1 term in the numerator. And looking to the denominator, there is x0 minus x1, x0 minus x1 and x1 minus x0. So this is the symmetry of this equation. This is for remembering the equation for L1. So when we put, what is L0 of x0? L0 of x is x minus x1 by x0 minus x1. Put x is equal to x0, you will get x0 minus x1 divided by x0 minus x1. So L0 of x0 is 1 and L0 of x1, what is L0 of x1? L0 of x1 will be 0. And what is L1 of x0? L1 of x0 is 0 and L1 of x1 is equal to 1. So these relations can be expressed in a more convenient form as Li of xj is equal to 1 if I is equal to j and equal to 0 if I not is equal to j. And also we can write sigma I is equal to 0 to 1 Li of x is equal to L0 of x plus L1 of x. Looking to this equation, this is L1 of x is equal to L0 of x y0 plus L1 of x by 1. And we can write what is Li of x. Li of x is just L0 of x plus L1 of x. L0 of x0 is 1 and L0 of x0 is 0. So 1 plus 0. So you will get L0 of x is x minus x1 divided by x0 minus x1 plus x minus x0 divided by x1 minus x0, and if we put L0 of x0, it will be 1 plus 0. If we put L0 of x1, it is 0 plus 1. In both cases, you will get the value of this equal to 1. So, the equation L1 of x is equal to sum of I is equal to 0 to 1 Li of x yi is the Langrange polynomial of degree 1 passing through 2 points. So what about a Langrange polynomial of degree 2 passing through 3 points? Polynomial of degree 3, degree 2, it is degree 2 passing through 3 points. So we can write it like this: L2 of x is equal to summation I is equal to 0 to 2 Li of x yi, and which is equal to L0 of x y0 plus L1 of x y1 plus L2 of x y2. And what is L0 of x? It is x minus x1. No, please note that there will not be any x0 terms in the numerator for L0. So x minus x1 into x minus x2 divided by, and in the denominator it is x0 minus x1, also x0 minus x2, plus what will be L1 of x, it will into y0, what will be L1 of x? It is nothing but x minus x0 into x minus x2 divided by, it is x minus x0 x1 minus x2 y1 plus what is the value of L2? It is x minus x1 into x minus x1, so x minus x0 into x minus x1 divided by x2 minus x1 into x2 minus x0 y2, or for this LIs must be satisfied the above two conditions, that is Li of xj is equal to 0 and is equal to 0 in this 1 in this condition, and also satisfy this condition also, that is L0 of x plus L1 of x plus L2 of x is equal to 1. So we have to find a general formula for nth degree polynomial. Let ln of x is equal to a0 plus a1x plus a2x square plus etc. plus an x raised to n. Let this is the nth degree polynomial that we have already assumed to be ln of x is equal to y of xi. Ln of xi is equal to y of xi is equal to y. And this is and when we put the values of different values for x, it is y0 is equal to a0 plus a1 x0 plus a2 x0 square plus an x0 raised to n. Next y1 is equal to a0 plus a1 x1 plus a2 x1 square plus etc. an x raised to n. Next we have y1 yn is equal to a0 plus a1 xn plus a1 xn square plus etc. plus an x raised to n. So this is we obtain the system of equations by substituting different values for x. So what will be ln of x is equal to I is equal to 0 to n li of x yi, as we written in the case of ln of L1 of x, L2 of x. We can write ln of x is sigma I is equal to 0 to n li of x yi. So we can write what is li of x. We can write li of x is ax minus x0 into x minus x1 into x minus x2 etc. into x minus xi minus 1. After that x minus xi plus 1, there is no xi term in the numerator is known this up to x minus xn all divided by xi of x0 into xi of x1 up to xi, so the xi minus x0, xi minus x1, xi minus xi minus 1, xi minus xi plus 1 to xi minus x. And this Li will also satisfy the relations Li of xj is equal to 0 and 1. The following conditions we have already discussed it, and also sigma Li of x is equal to this sigma I is equal to 0 to n. Li of x is equal to L0 of x plus L1 of x plus L2 of x plus etc. plus Ln of x is equal to 1. So we can make, this is the general formula for the Lagrange's polynomial. This is the Lagrange's interpolating polynomial of degree 1. You have to substitute the values of L1, L2, L3 up to Li. And what is the value of Li? Li is this term, and from this you can find the interpolating polynomial of nth degree, and we can write this equation to a more compact form by setting a n plus 1 of x is equal to x minus x0. We know that we can write pi of n plus 1 of x is x0, x minus x1, x minus x2 up to x minus n. And also when we take the first derivative of this term, xi is equal to d by dx of pi n plus 1 of x is equal to xi. This is the meaning of this term, and that will become, just to take the derivative, you will get xi minus x0 to xi minus x1. Put x is equal to xi and take the derivatives. You will get it like this, into xi minus 1, xi minus xi plus 1, there is no term, xi minus xi up to xi minus xi. So we can write Li of x is equal to pi n plus 1 of x that is Li of x equal to en plus 1, this is the product term, plus 1 of x. Here there is a term x minus xi. We have to eliminate that, so we just divide it by the term x minus xi into the denominator of this is this xi minus x0. It is nothing but pi prime of xi. So pi plus 1 prime of xi. So we can write the Langrange's interpolation formula like this. Ln of x is equal to sigma I is equal to 0 to n by n plus 1 of x plus 1 of x divided by x minus xi into n plus xi into yi. This is the Lagrange's interpolation formula of nth degree polynomial. And Li of x is called this is the Li of x is called the interpolation coefficients. Li of x is called, this is called interpolation coefficients. And we can also find the inverse interpolation to find ln of y. What is ln of y? Using y values we can find the polynomial in x. Ln of y, just replace the values of x with y. So pi n plus 1 of y divided by y minus yi, pi prime of xi into, sorry, this is not xi, this is yi, yi into xi. So this is called inverse interpolation formula.